Hello, we're going to talk about 10-5 today, experimental probability. Okay, now there's kind of a lot of definitions in this section, so make sure you pay attention to what we're talking about with each word. So, an experiment is an activity involving chance. Every time we perform an experiment is called a trial, and every result we get is called the outcome. There's something called the sample space, which is the set of all possible outcomes of an experiment. So in this chart here, for example, an experiment might be rolling a number cube. So every time we roll it, it will be called a trial. And then every result we get is called the outcome. The sample space would be our possible outcomes. Well, we could get a 1, 2, 3, 4, 5, or 6. So that's what our sample space would look like. Another example of an experiment would be tossing a coin. Two outcomes possible there, heads or tails. So our sample space is heads or tails. Or another possible experiment would be spinning a spinner, and here you can see we have four colors: red, blue, green, and yellow, so that would be our sample space. So the very first thing we're going to do is just identify sample spaces and outcomes. So here it says rolling a number cube, and has a picture of the number cube for you. So what would the sample space be? Well, a cube has 6 sides, so we could get a 1, 2, 3, 4, 5, or 6. That would be our sample space. The outcome that is shown here, the number on top, is a 4. Okay, spinning a spinner, 4 colors. Looks like we got red, purple, green, or yellow. And the outcome shown here is green. Okay? So those are pretty easy questions there. Just list the possible outcomes and then the outcome that is shown. Now, we want to start talking about events. So an event is an outcome or a set of outcomes in an experiment. And what we'll be doing is finding the probabilities of the likelihood an event will occur. Sometimes we can write them as fractions or decimals or percentages. Most likely you will see them either as fractions or percentages. Okay, and when we have these probabilities, we can then classify events by whether or not they are likely or unlikely to occur. So what will happen in this part here is you'll be given a situation and you'll be asked to say, is it impossible? Meaning that there's a 0% probability that will happen. Is it unlikely? Meaning it's between 0 and 50%. Is it as likely as not? Meaning it has a 50% chance of happening and a 50% chance of not happening. Is it likely? Meaning it has a probability between 50 and 100%. Or is it certain? Meaning it has a 100% probability. And that's what these look like. So we want to classify these as impossible, unlikely, as likely or as not, likely, or certain. So a shoe is selected from a pair of shoes that fits the right foot. Well, we have 2 shoes in a pair, so that means we would have a 50-50 shot at getting the one that goes on the right foot. So this would be as likely as not. Katrina correctly guesses the last digit of a phone number. Okay, well, phone numbers, okay, last digit, so we got from 0 to 9 that it could be. So, and one answer is right. So really, if you think about it, it's like 1 out of a 9 shot that she would get it right. So that would be less than 50%. But she does have a chance, so we would call it unlikely. Max pulls a green marble from a bag of all green marbles. Well, he can only pull a green marble, so it would be certain that he would get a green marble if his only options are green marbles. And then we have a randomly selected month contains the letter R. Well, let's think about what letter or what month contain the letter R. January, yes. February, yes. March, yes. April, yes. May is no. June is no. July is no. August is no. September, October, November, December. So if I count right, that's going to be 8 of the 12 months that have the letter R. So that's higher than a 50% probability, so we would classify this as likely. Okay, so that's what those problems look like. Next we want to start talking about what is experimental probability. Okay, well, experimental probability is the ratio of the number of times the event occurs over the number of trials. Okay, so if I'm performing an experiment, however many times I get the event divided by how many times I perform the trial is the experimental probability. So for example here we have, we're spinning a spinner, we have the results in the table. We want to find the probability that the spinner will land on orange. Well, it landed on orange 10 times, so that's going to be my top number. That's the number of times it happened. Now I have to do the bottom number, which is the number of trials. So that's going to be 15 plus 10 plus 8 plus 7. And if I do my addition right, that's 40, so that's 10 over 40, which would be 1/4. So there's 1/4 of a chance, or 25% chance, that it's going to land on orange. Okay? Let's look at another one like that, a different table here. What's the probability that the spinner will land on red? Well, the spinner landed on red 7 times, and there was a total of 7 plus 8 plus 5 trials, which is 20. So we get 7 out of 20 are the odds, or the probability, that it will land on red. Now what about the probability that it won't land on red? Well, that would mean it would land on blue or green. So that happened 8 plus 5 times. We still have 20 trials. So the probability that it would not land on red would be 13 out of 20. Okay, so that's how we calculate experimental probability. Now the last thing we want to do is use this experimental probability to make predictions. A prediction is an estimate or a guess about something that hasn't happened yet. So a manufacturer inspects 500 strollers and finds that 498 of them have no defects. What is the experimental probability that a stroller chosen at random will have no defects? Well, let's figure that out. Okay. We have 500 total strollers, 498 no defects. Okay, because we want the probability that there will not be a defect, not the probability that there will be a defect. So we'd have to do 498 over 500. And if I go ahead and divide those, that's 99.6% chance that it will not have a defect. So, knowing that, let's say the manufacturer ships 3,500 strollers to a distribution center. Predict how many strollers will have no defects. Well, we know that 99.6% of these have no defects, or according to our experiment. So we want to take 99.6% of 3,500. Well, let's change that to a decimal, so 0.996 times 3,500. Okay, and if we times that together here, that means that our prediction is that 3,486, so 3,486 strollers will not have a defect. Okay, so that's how we can use our experimental probability to make predictions about things, and that's probably the most useful part of probability. Okay, so that's it for 10-5. If you have any questions, let me know tomorrow.